reminder from our problem of the day, if I ask you to find places of horizontal tangency, horizontal tangents have slopes of 0, so we set our derivative equal to 0. Okay, you're going to have some problems like that in your homework tonight. I just want to make sure we tackle them. Okay? Let's go ahead. I know that you wrote one already today, but I want the equation of the tangent line when x equals 2 for f of x equals 6 minus x squared. So go ahead and write f of x equals 6 minus x squared at x equals 2, so you know what we're talking about. Okay, as a reminder, you need two things. You need slope and you need a point in order to write your tangent line equation. Right now we have neither of those things. Which one would you like to take care of first? Okay, and in order to find slope, what do we need to find first, Max? Okay, and isn't this so nice? It's going to take us 3 seconds. What's the derivative of 6 minus x squared? Be careful. Negative 2x. So much faster. Okay. In order to find the slope for our tangent line, is negative 2x our slope for the tangent line? It helps us find it, but you're not using negative 2x in your tangent line. You need to actually evaluate your derivative. So at 2, what's our slope? Negative 4, because we plug 2 into the derivative to figure that out. Okay, so we have our slope. Our point, what do we need from our point? We have x, we need y. And how do we find y? We got to go back to our original equation. Okay, so what is f of 2? 6 minus x squared. F of 2 is 2. So our tangent line equation is y minus 2 equals slope times x. Okay, so we had 6 minus x squared, right? In our tangent line equation, negative 4 times x minus 2, and then I could add 2 over. So there's our parabola, and there you can see at x equals 2, at x equals 2, you can see our tangent line. Okay, now that's not actually what I want to show you in your calculator, but I want you to get visuals of what we're finding, right? We have our function at a point. We found the line that is tangent to it. Now, I'm going to get out of this. Your calculator can actually calculate derivatives at a point. You can't like plug in a function and it give you out a derivative, but you can plug in a function and an x value and it'll tell you what the derivative is there. Okay, so I'd like to show you how to do that. So everyone has their calculator, and just real quick, go to mode and make sure that it's in radian degree in case you ever use this with a trig function. It would need to be in radian degree. I mean radian mode. Sorry. Sorry. Wow. Monday still. Okay. So everyone, math 8 is the command. So if you hit math and then 8, that's the command you want. Look up here. Raise your hand if yours does not look like this. Everyone has this? Like nobody has Like not the empty boxes. Nobody has like a parentheses. Max? Yours does not look like mine, does it, Max? Okay. That's what I needed to do. Okay. For everyone else, follow me. Max, just be patient. We need to say that we're taking the derivative with respect to x. So we need that d dx. Inside the parentheses, you're going to put your function. So 6 minus x squared. And then at that evaluate bar, you're going to plug in whatever x value you want it to be. Max. What it? Okay. So Max, you're going to have to. So open a parentheses for you, right? Does it have like ddx? Is that?
It says
n derived. That's right. N derived. So you're going to plug in the function. So whatever it is. So 6 minus x squared. And nobody has this n derived. Okay. Comma, you have to tell it what variable, so comma x, and then comma the x value. Because you don't want to close it. It's all one thing. Okay, so let's try another one. How about you find the derivative find the f of f prime of 3. So instead of finding the derivative and then plugging in the value, you can simply just put it on your calculator. And I made this up on the spot, so I have no idea what the answer is. A giant number, probably.
Yeah.
9 to 8 what?
9, 7, 8, 9, 8.
Oh, you don't want to use one.
Okay, so in calculus, we always round to 3 decimal places. That's the number that you got. Okay, this is the number that your calculator should be spitting out.
Oh, I get it.
Max is struggling today. That's okay.
I said X squared.
Okay. Nine, 7, 9. But if I tried to round to 8 up to. Like that. Because this was an 8. I thought it was a 9. Okay. I do not want you to use this for a problem. I want you to use it to check your work. Okay? We are not to the point yet where I want you to be finding derivatives in your calculator, but it is a way for you to check your work as far as you find a derivative, you plug in the value, you can use your calculator to check. Okay? We will get to a point where you can use the math 8 command instead of finding a derivative, but we're not there yet. But you can at least use it to help you. So, let's talk about a couple other concepts that are going to be important for the rest of the chapter. Okay? Average rate of change is something that you talked about at least in pre-calculus, if not in algebra 2. Average rate of change. First of all, what does it make you think of? Slope. Probably has something to do with slope. Okay? Does anybody remember what slope we are finding when we are finding the average rate of change? So the derivative is a tangent line slope. Okay? So the average rate of change would be the slope of, not a tangent line, but a, more or less, yes, okay. So only linear functions have slope, right? So what if we have a function that's not a slope? We can pick 2 points, and we can find the slope between those 2 points, and we would describe that as our average rate of change, okay? So the average rate of change is essentially the slope of the secant line from a function, okay? Literally, it's just rise over run. Calculate the slope between 2 points. We're just not on a linear function, okay? We're on some sort of other function. Okay, so when I'm asking you for the average rate of change, you need 2 coordinates, change in y over change in x. That's all it is. Y minus y over x minus x. Okay. So now we have 2 rates of change that we have to keep straight. We have average rate of change, okay, which is the slope between 2 points, right? Versus instantaneous rate of change, the slope at 1 point. Okay? And you have this already written down somewhere, right? But I need you to understand the difference. Average rate of change and instantaneous rate of change. And often you will hear them being used in one problem. So you need to differentiate between the two. Okay? Unintended there. Instantaneous rate of change deals with the derivative slope at 1 point. Average rate of change, slope between 2 points. That's like algebra 1. Okay? But what's nice is they both involve rate of change, so you know it's a slope of some kind. Okay? Okay. So we are going to find both the average rate of change and the instantaneous rate of change of a function. If I ever ask you for average rate of change, you should be given an interval. Okay, we need 2 coordinates, right? We need a start and a stop. So every time I ask you for average rate of change, it will be over an interval. Okay, here we go. We have our same function, f of x is 6 minus x squared, and I want the average rate of change from 2 to 5. Well, if we're going to find the slope between 2 points, what do we need? You need your 2 points. We have the x values, but we don't have our y values. So we need to figure out what f of 2 is, and we need to figure out what f of 5 is. Okay. What's f of 2? What's f of 5? Negative 19. We have 6 minus 25. So our average rate of change, okay, average rate of change, okay, would be change in y over change in x. So what, negative 21 over 3? Oh, well, I guess we could. That would probably be helpful. If you don't simplify, am I going to throw a fit? No. You don't have to simplify, but I mean, in this case, when it's an integer, you might as well. Right? Okay, so this is the slope between these 2 points on this function. Versus, if I ask you for the instantaneous rate of change at x equals negative 2, then that is just asking for you to calculate the derivative and plug in negative 2. So, if you would like to write them, you go for it, buddy. I'm just going to write f prime of x. We already determined that our derivative is negative 2x. And so our instantaneous rate of change at negative 2 specifically would be 4. Because we plug in negative 2 to the derivative. And here's right. All right. What do you think so far? Anything life-changing? Okay. Yes. Okay, so your homework quiz. Okay. Your quiz on Wednesday. Okay. So 3 major things from this so far. Write the equation of a tangent line. You've done that for like 3 days now. Horizontal tangent points. We did that in our warm-up. Average rate of change versus instantaneous rate of change. So those are like the 3 big things from today, right? Along with find this derivative, find this derivative, find this derivative, find this derivative. Okay, that's really what your quiz is going to be. Okay, there will be one question where I make you use the limit definition, but what's nice is we now know what your answer should be. It's a matter of getting your work to match it, right? We know the power rule, so we know what the answer is going to be. So you got to have all the work to go along with it, okay? The hardest part of your quiz is just rewriting the functions to make sure you can use the power rule, okay? It's not a scary quiz. But there is one last thing that we need to talk about in our 8 minutes that we have left, okay? Falling objects. It is exactly like physics.
I wish we had this
A couple weeks ago.
Extra practice. Yeah, we got our test back today.
Yeah.
We got a massive scale.
Yeah, and the grades are still open. Yeah.
Are you in the way? What does G stand for? Gravity, the pull to gravity, and the pull to gravity, the gravitational pull is negative because it's bringing objects down. So that leading coefficient is always going to be negative. Okay. G is either going to be 9.8 meters, negative 9.8 meters per second squared, or negative 32 feet per second squared. You're actually going to see that more often. Okay? V sub 0 stands for, okay, what does V naught stand for? Initial velocity. Okay? If you're dropping something, the initial velocity is going to be 0. But if you're throwing something towards the ground, you're going to have some sort of initial velocity. And if it's in the downward direction, it's going to be negative. Okay? And then S naught. Initial something else. Initial position. Okay? So here we have gravity, initial velocity, and initial position. Now, the velocity equation, don't write anything down yet, but this is the velocity equation. Make an observation. It's the derivative.
Whoa.
Come on.
She uses them.
Does this like make sense? When we did physics a couple weeks ago? Okay. Okay, the velocity is the derivative of the position. And we'll actually spend an entire unit in February on motion. This is just kind of like your little introductory taste of it. Okay.
And that's why it goes from being square to linear. Oh my gosh! This why would we taught this way? This makes sense now because in physics, like when you draw the graph, it goes from linear, like square.
Yeah. Okay, and let's also think about velocity is a rate of change, right? Velocity is the change in distance over time, okay, at any instant. It's the instantaneous rate of change of the position, okay? It's the derivative. This is great. Okay. Okay, so I feel like you're all really going to appreciate this problem. A physics book is thrown down. Perfect. From the top of a 220-foot building. It's kind of the vibe I'm getting right now. What's other physics you read? If I start doing that. Okay. So 220. What is that?
That's your initial.
That's our initial position. And since we're throwing it down with initial velocity, we're throwing it down. V naught is negative 26. Okay. Which means, which gravity are we going to have to use? Yep. Okay, so our position equation would be 1/2 times negative 32 t squared plus our velocity times t plus our initial position. So negative 16 t squared, that is 1/2 times negative 32, right? Okay. Plus v naught t, so minus 26t plus 220. Okay, now it's just a matter of what are they asking us to find and how do we find it. Okay? Our velocity equation. If this is the position, our instantaneous velocity equation, what do we do? Okay, and our derivatives, Courtney, rattle it off for us. What's the derivative of this? Yeah, they do the thing.
Now, it's gonna save time on B, on 3B, this would save time on.
Okay, our velocity equation, our derivative, power rule, power rule. Negative 32t minus 26. Okay, now, the bell's gonna ring in like 20 seconds, and so I'm not gonna get to finish this problem. This is what I want you to do. Do what you can from your homework, and for sure we'll spend a little bit more time going over these problems from your homework than the other ones, but just try and see what happens. You never know, you might surprise yourself. Okay? What? It is.
We need to list all of them.